Okay, so to continue, we look at number 24, right? Number 24. So we've moved on to the next instruction, which is this one over here. Oh, this one over here. We've moved on to this instruction. Okay, so number 24, we're at 0, 5b, right? So what do we do afterwards? First of all, what is our for number 25, what is our memory address register? So here we're fetching from memory address, this one. So we're fetching from this memory address, right? Then now we're going to say, okay, what is going to be our 26? What's the content of our memory buffer register? Our memory buffer register will have the contents of what we're fetching from our memory. In this case, what are we fetching from memory? We're fetching this stuff over here, right? So 0108A 0F 05D. So we're going to say 0108A 0F 05D, right? Then now our accumulator, we haven't touched our accumulator yet, so we're going to have FF, just those F's then be there. So now 28 will have our first instruction, right? Line 28 will have our initial instruction, which is going to be 01, right? Line 29 is our buffer register. So number 29 is our buffer register. It's going to have 0F05D. Then number 30 over there is our program counter. Our program counter, which is still at 05B, because at this case we haven't moved our program counter. Then now 31, we have our memory address register. Since we're in the execute cycle, our memory address register is going to be the address from this instruction, which is 08A. Okay, what is 01? Same as we had here. 01 is just load the contents of memory, load the contents from this memory address into the accumulator. We haven't touched our memory address yet, so this one, the accumulator stays the same, right? So for this one, our accumulator at line 32 will just, so our buffer register first of all will just be this is line 32, right? Our buffer register will be the contents of this address, which is just FF F and then a B there, right? And then our 33, our accumulator will just be the same thing. Our F there, those F's and the B at the end, which is, remember, this is -5, to come in handy on the next instruction. Let me just move this. Okay. Then 34. What is 34? 34 is our instruction register. 34 still stays the same as 0, 01. Then 35, our buffer register is just 0F05D. What will 36 be? 36. Well, this is so we've basically executed this first hand instruction, right? We've executed this part of the instruction. We're then going on to the next one. So for 36, our program counter will still remain as 05B, right? But then we're going to go on to our memory address register, which is this memory address 05D, right? We're going to get this memory address from this instruction, because if you remember, when we're executing the left hand instruction, for left hand instruction, our MAR will have the same as the program counter in the fetch cycle, but in the execute cycle we get this one. But then for this other one, when executing this other instruction, from the get-go we just use the address in the instruction, right? So that's why this one now will have 5D, because our instruction, this one, it has 05D. Okay, then our 38, what is our accumulator? Our accumulator is still those contents that were there, the 0, the F F B, right? 39, right? 39 being our accumulator. 38 is our MBR. Yes, 38 is our MBR, which we haven't touched yet. So our accumulator is this one. So for now, we haven't fetched anything from memory, so this is the last thing we fetched from memory. Number 40 is our instruction register. What is our instruction? Our instruction is currently 0F, right? what will be in our buffer register? It will still be 0F05D, because we haven't what's this? We basically haven't cleared that register anyway. Then now for 41, right? Then now we go on to our execute cycle. 42, we now change that to 5C, right? Then we have we're going to execute this instruction, right? So firstly, we're still at 5D in our memory address register, right? This is at number 43. And then first of all, we're going to look at what is this instruction saying. This instruction over here, 0FFF0, is this one over here. This one, red ink. So it's this one here, 00001111, which is jump. So if the number in the accumulator is non-negative, then take next instruction from left part of fx. So basically, what this 0f is saying, if the value in our accumulator is non-negative, if it's positive, we're going to get the instruction from here. We're going to start from here. But the thing is, this over here is -5. So our program continues executing just like normal, right? Since that is just a -5 there, so our program will execute just like normal. Okay? So now, what is at 43 now? 43 will still have that address. Our memory buffer register, it will still have FF, right? So that FFF FB, right? Our 45 will still have that FF FB there, right? And then now our 46. Our 46 is our instruction register, which still has the 0F, because I'm interested in instruction. And then our 47 again still has 0F05D. Okay. Then now 48. It's going to be our 48. 48 is now the 5th instruction cycle. We start at 05C, because remember over here we said only if the number is non-negative, but in here this is -5. So if you do 2's complement on this one, because this is just 1 1 1 1 1 1 1 1 1, we have a bunch of ones there, and then after that one we're going to have 1, right? We're going to have this one. B is 11, so we're going to have 1 0 1 1. Now we can ignore all these ones and then just have a 1 1 0 1 1. This is going to be -16 plus 8 plus 2 plus 1, which is going to be -8, right? -8 plus 3, which is just -5, which is how I calculated this -5 here. So if you do 2's complement on this one, yeah. So from there we're on 49, right? This is a long question. We're on number 49, 05C. So 49, what are we doing there? 49, we're getting the instruction from this memory address, right? Then 50, buffer register, we're going to get everything from that memory address, which is 0208A 2108B, right? Then for 51, our accumulator still has that -5 in there, right? And then for 52, we are executing this instruction. For 53, our buffer register is going to have 2108B, which, if you remember from here, this is just the store. This is just storing, right? This is just store. So yeah, but we're going to execute that in our final instruction thingy. Okay, what next? My goodness. 54. 54 is this is where the execution cycle starts for this one. We're still at 05C, right? We haven't incremented our program counter just yet, right? We're still there. On to the next page. Yeah, this is a long question, but luckily we are done for the most part. So for 55, what is our memory address register? 08A, right? Because remember, this instruction that just came in was 0208A. Now for 56, our buffer register. First of all, we need to understand what is this instruction doing. This instruction is this one over here, 0 0 0 0 0 0. Then we have a 0 1 0 there. So it's 0, 1, 0. Okay, 0, 1, 0, 0, starting from the least significant bit. So 0, 1, 0, 0. Then we have 4 zeros that side. This is basically transfer negative of the mx to the accumulator. So basically, we're transferring the negative of the mx. Now, what's the negative of negative 5? The negative of negative 5 is 5 itself. So here we're just going to load 0, 0, a bunch of zeros, 0, 5. We're just going to load in 5. Again, to do this conversion, basically, these are, if we start off with what's this? If we start off from the 2's complement, f, 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 b there, right? This is just all ones, right? We're just going to have a bunch of ones there continuously. And we're going to have our ones here for this f. I'm going to have 1, 0, 1, 0, 1, 10, and it's going to be 11 there, right? Then now, this is currently in 2's complement. To convert back to our normal form, first of all, we take it to 1's complement by subtracting a 1. So we're going to have a continuous number of ones there, then 1, 0, 1, 0, right? Then we're going to find, then we're just going to invert this, because this is 2's complement. Now this has converted it to 1's complement, and then this 1's complement, we're just going to make all the ones zeros and all the zeros ones. So I'm going to have 0, 0, 0, all the way up to here. We're going to have 0, 1, 0, 1. This is 5. Right? So this is just converting this back into binary. And then if we group those now as hexadecimal digits, we're just going to have 0, 0, 0, 0, 0. We're going to have zeros there, and then we're going to have a 5, which is this here. I think we're going to have how many zeros? 1, 2, 3, 4, 5, 6, 7, 8, 9. We're going to have 9 zeros and a 5 at the end. So it's 9 zeros and a 5 here. I'm writing like this to abbreviate. Yeah. So we're going to load that 5 there, right? Then what is our 57? 57, our accumulator now becomes just 0, 0. All those 0, 0, 5 there. 58, instruction register. What instruction are we executing at 58? We're executing 0, 2. Which is the same instruction that we have there. And then our buffer register still has 2108B, which is just the store function there, right? Okay, almost done. Thank goodness. 60, we're at the next instruction, right? We're at the next instruction, the last one, finally. So it's going to be 0, 5C, right? Then what is at 61, right? 61 is our memory address register. What memory address are we focusing on? This one, 08B, right? The memory address of this one over here, right? Then our accumulator at 62, or our MBR still has 0005, still has just a 5 in there. We can just leave it as a 5. It's fine. Then skipping. Oh, sorry, I'm not skipping. I have a book over here. I don't want to start lying to you guys. This thing was hard. Then now, 63. What is going to be 63? Our accumulator is also still going to be just 5. I can just write it as 05 there, just 5. Then our 64, our instruction register. This one will have a 2, 1. This one there, right? Our instruction buffer register, we haven't cleared that, so it's going to be that there. So I'm making a mistake on the. Yeah, we don't clear the buffer register anywhere. Yeah, we don't clear the buffer register anyway. So. Yeah, and if you've seen the way we go, we'll just go back to that. Okay, anyway, it's fine. Anyway, where was I? Okay, so what is at line 66? Line 66 now is our program counter, and then this one, as per tradition, we just increase that to the next instruction, right? What is at 67? 67, our memory address register. We have the memory address. This is a P here. We have the memory address of our instruction, which is 08B. What will be at line 68? Line 68 will be the contents of our buffer register, which is nothing. Which is this is now coming from the accumulator, right? So remember, this is just this one, 21 is basically store the contents of the accumulator to this memory address. So we're going to get what is the 5 in the accumulator. It goes through the memory buffer register, and then finally, our instruction register is 21. Our buffer register is 2108B. Yeah, this is how I understood the question. Yeah, hopefully that was clear. Otherwise it was a bit rough, huh? But yeah, this is how I understood this question and interpreting this flowchart. Yeah, Of course, I also have my doubts somewhere as well. I'm not, as in, I'm not a lecturer, so I'm also just a student. But anyway, my only doubt is on the instruction buffer register. But for the most part, yeah, this looks valid. Yeah, this looks valid. So yeah, I also tried implementing the same program in the IAS simulator. Yeah, so I translated that into the IAS simulator. Even though the IAS has different instructions, like the way they are laid out, yeah, or the way you write them. But for the most part, I got a similar result in the end. I had a 5. So at least, meaning the last part of this question is what is the final value of address 05B. That one, the final value of address 05B is 5. We're just going to have a 05 there. It's going to have a 05. We can write as 0, 0, 0, 0, 0, 0, 0, 0, 0, 5. But you know, this is just redundant. But yeah, this is how you go about solving such a question. Yeah, I've never done such a long program execution myself, but anyway, yeah, see you.